So today we're going to be learning the ins and outs of sorting. And I just want to give you a brief warm-up question to think about. If I were to sort a column by both the numbers and words, how does the computer know which comes first? Because we may be familiarized with sorting, right? We do an alphabetical order, we do a numerical order, either that in increasing or decreasing. But if we were to combine both of these two things, how would you go about sorting them? So here, I'm just going to give some examples of some of the more simple base cases. So if we look at the documentation here, we can see that we are sorting and we have to be working with a data frame, and we're going to specify a column name. And then we're also going to specify ascend is equal to true. That is the default argument. But if you want to do the opposite, you can say ascending is equal to false. So let's give some examples. Um, So here we have ascending is equal to false, where we're going to be sorting by the name. And this, the way you can think about it is reverse alphabetical order, where T comes later than N comes later than M, L comes later than K, and then so forth and so on. But if you wanted to have it in alphabetical order, we can just remove this, right? And it'll instead have the A's at the very top, then B, C, D, and E, and then so forth and so on. And of course, you also could just put ascending is equal to true, and it will function the same way as so. And then next, we can also sort by score, where the lowest score is at the very top, and then it goes to increasing order or ascending order. And just to give you like a visual representation of ascending is equal to true, when you're ascending a flight of stairs, you are going to the top. And then sorry, that's um, not the best visual representation. And if ascending is equal to false, well, that is the same way as descending, right? Your ascending is equal to true as you actually are ascending a flight of stairs. Your ascending is equal to false in the same way as thinking of descending order. And that's the best way I like to think about these arguments. Okay, but now let's introduce the problem where if I were to give some additional characters, so let's say every single person on this data frame has a favorite character, and it's so happens to be very different, right? There's A's, there's Z's, there's 0, 9, and a period, with uppercase and lowercase is in there as well. And if I were to sort by this favorite character, you'll see that the period comes at the top, then we have the numbers, then we have the upper cases, and then we have the lower cases with alphabetical order being preserved within these two rows. But why does this happen? And the way I want to bring it to you is that the computer thinks in the worlds of ones and zeros. Because it does that, we are able to actually represent any single number with these ones and zeros using binary. I won't go into the depth of how binary is calculated, but just know that there is a binary representation for every number. Um, and because we can do that, we can represent numbers infinitely. um, we can give every single character a number. And so we come up with this thing called an ASCII type or an ASCII table, where you can think of like the number 0 is assigned to ASCII value of 48, the number 9 is assigned to ASCII value of 57, the capital A is assigned to ASCII value 65. And so when we have this sorting, it doesn't necessarily look at the capital A, it doesn't necessarily look at the number 0, it looks at the ASCII value itself. And if I were to show you this ASCII value within the table using the ORD function, you can do Shift Tab on the function to see what it does, and it returns the Unicode value of it. You can see that, yes, it follows that precise number of capital A being 65, lowercase a being 97, and then so forth and so on. And so we are essentially sorting by these hidden values that you aren't seeing quite. Sure, you might think sorting by alphabetical order, sorting by numerical order, either in ascending or descending order. But if I were to sort by my favorite character, right, we still have the same order of period 0, 9, A, Z, uppercase, A, Z, lowercase. But it actually looks more so at this ASCII value that isn't being shown. 46, 48, 57, 65, 98, 97, 122. So yeah, that's what I want to show you is that the sorting is not random and that it thinks in the worlds of ones and zeros. Thank you.